So hello everyone, today I'll be going over how does exercise associated genes explain the phenotypic variance in the three components of fitness. Again, this is a systematic review and meta-analysis. So the first slide here is going to be the introduction. So again, in the introduction, we're going to go over how fitness improvements vary widely between individuals who follow the same training. And then again, some people are high responders, and then others can be no responders or low responders. And then again, genetics influence how well someone adapts to the three training fitness components. Again, the three training fitness components are going to be cardiorespiratory fitness, which again is just another word for VO2 max, muscular strength, and then again, anaerobic power. So VO2 max is highly linked to reduce morbidity, improved function, and then again, just overall increasing your lifespan. Muscular strength is needed for independence, mobility, performance, and then overall injury prevention. And then again, the last one here, anaerobic power, again, is going to be crucial for speed-based tasks, explosive sports performance, agility, and then just overall neuromuscular function. So something we're going to talk about here is a guy named Claude Bouchard. Again, he was the first scientist to prove that genetics play a major role in how the body adapts to exercise. He led a study called the Heritage Family Study. Again, this was the largest research project examining genetics and exercise response. So again, he introduced the concept of trainability phenotypes, which revealed the genetic potential or genetic makeup that predetermined training outcomes even before the training program has even started. So again, why does this matter? Burchard's work laid the foundation for current studies to investigate which specific genes contribute to aerobic strength and power adaptations, and then again, how much of the variance they can explain. So the study purpose, again, just starting off, the primary purpose was to identify which candidate genes and alleles are associated with improvements when it comes to VO2 max, muscular strength, and then again, anaerobic power. The secondary purpose was to determine how much of the variance in training adaptations can be explained by genetics in previously untrained adults. Again, so going to the next slide here, we have the methods. So again, this just goes over how each individual study was used and the criteria that was used to pick the studies for this overall systematic review and meta-analysis. So in this slide here, we have the flow chart. Again, it kind of just goes over the initial results and then how they narrowed it to the 24 studies. So something just to kind of note, over here on the picture of the flow chart, it says 29, but again, 5 studies were excluded from the 29, again, because the genes in the studies were only reported on one occasion. So at the end of all this, they used 24 studies. So the first thing we're going to go over is results for VO2 max. Again, the two main things to take away from the results here are going to be VO2 max increased by 11% on average across all studies. And then again, the most important thing to note here is 44% of the training response variance explained by genetic difference. Again, individuals with certain genotypes show greater natural improvements with training as well. So the results for muscular strength. So the most important two takeaways again with muscular strength are going to be strength improved by 22% on average, again, across all studies. And again, the most important one here is 72% of the strength variability explained by genetics, again, which was the highest of all the three fitness components. The last one here is anaerobic power. So again, the most important thing to take away from this anaerobic power is again 10% of training responses explained by genetics. So again, power adaptations may be more influenced by neuromuscular and training factors than genes. So the conclusion. So again, genetics significantly influence training outcomes. Again, as we see here, strength went up, or strength was 72%, aerobic was 44%, and then again, power was 10%. Again, why does this matter? Because this supports the shift towards a more personalized exercise prescription rather than just a generic one-size-fits-all program. So again, let's start from most important to least important. So starting off again, just going back to the previous 3 slides. So strength went up 72%, aerobic was 44, and power was 10%. And again, multiple genes are responsible. Again, not just one performance gene determines the response. Then again, different genes impact different fitness components. Personalized and genotype-based training has a future for potential to maximize performance and reduce those non-responders. And then again, connecting to other research phases. So just starting off with biological fitness, so explains biological and genetic determinants of individuals and why they respond differently to different types of training. And then again, we have valid and reliable instruments. So this is going to show potential for genetic testing to become a future assessment tool. So the next one here, we have systematic and meta-analysis. So this article represents a high level of evidence. Again, this is just going to support the genetic influence on fitness. And then again, program design. Again, this is going to shift us from that one size fits all program design to that more of that individualized training program concept. So practical application, again, here it just supports individualized training programs, the potential to use genetic profiling in the future, and then again, improvement when it comes to training efficiency and athletic and athlete development. And then the last one here is foundation for precision, for like precision, precise, accurate exercise prescription. Some strength and weaknesses. So starting off with strengths. So this study was included high quality studies only. It was the first review to examine all three fitness components together. And then again, it quantified genetic influence. And then most importantly, again, it was just a robust systematic review and meta-analysis approach. So some weaknesses with this. So it had limited allele-specific reportings. It was a small sample size. And then again, most studies examined only one gene. And then again, it really only focused on untrained adults. Just future studies, or even to maybe make it a strength, they could focus on maybe like youth athletes, trained adults, and et cetera. So again, yeah, here we go. For future studies, so future studies should examine specific alleles. Research should analyze multiple genes together. And then again, like I said previously, it should include trained athletes, youth, and then again, just a diverse population in general. And then also the study should examine how training affects lifestyle, sleep, and nutrition as well. So just to kind of get my opinion on it. So again, I just think this research enforces how important it is to recognize that everyone responds differently to training. And then again, as a coach, it's kind of hard to rely on that one size fits all approach. So if we could get uh, to the area or get to the space to where we're now individualizing training programs for people, I think that's just going to put us in a much better spot in the future. And then again, although genetic testing isn't ready to be used yet, it is encouraging and it just helps coaches pay closer attention to how each athlete adapts and to just make quicker adjustments for individuals who aren't responding well to the current training program. And then again, just moving forward, we could design programs that offer multiple pathways towards the same adaptation so each athlete can progress based on their own biological response as well. Thank you.